What we're going to do is we're going to go through the Chapter 9 hypothesis testing using Webassign and my hypothesis Test-o-matic program. So let me bring up the problem that I wanted to talk about, and this was actually problem number 3. And so in Excel it says this: we've got the mean number of sick days an employee takes per year is believed to be about 10. So members of a personnel department do not believe that figure. So what they do is they randomly survey 8 employees. Well, the number of sick days they took for the past year was as follows for each of the 8 employees: 11, 5, 14, 4, 9, 10, 7, and 9. So we're going to let X be the actual number of sick days that they took for the past year. Should the personnel team believe the mean number is about 10? So let's conduct our hypothesis test. And remember that the way the hypothesis test goes is as follows. Step 1, state the null hypothesis and the alternative hypothesis. So here's our choices. Is it that we're saying that the claim is that the mean is not 10? That the mean is less than 10, equal to 10, or than or equal to 10? Well, let me get a vote here from Jason and Nick. What do you guys think? Should it be, which one of these 1, 2, 3, or 4 choices, A, B, C, and D, should it be? Well, in this case, yeah, it looks like we're going to say 3, right? Because the way that I stated my null hypothesis, I'm going to agree with you, Nick, is that our null hypothesis is stated as an equality. So there's a claim that it's believed to be about 10 days per year, right? Our alternative hypothesis, however, was that it says the number of sick days per last year. They don't indicate whether the human resources department, the personnel department, says that it's greater than or less than. They just say that, well, it's not 10, whatever it is. So we're going to hit our alternative hypothesis that it's just not equal to 10. All right, so here's some information. So let me bring up my Test-o-matic program. By the way, this is available on Canvas. This is what it looks like. And we have 2 types of tests that we can use. We either use a t-test or a z-test. Now remember from last week, the t-test is used when we have a very small sample and or we don't know what population it comes from. Well, this is a sample of size 8, so I'm going to say that this is the case right here. And so in the program, what I'm going to do is I'm going to enter in my null hypothesis, which is that the claim is that the mean is actually 10. We want to enter in which one of these 3 null alternative hypotheses it is, and in the program we actually just enter in A, B, or C. We don't actually have to write it out. If we were doing it by hand or writing this up for somebody, though, we would definitely want to state our null hypothesis this way, because not everybody has the Professor Peeples hypothesis Test-o-matic program. So we have to state it for them. What's our sample size? Well, they said there were 8 employees. Now, here's the tricky part. What we have to do is we have to go through and we are going to have to get our own sample mean. So we're told that we have these numbers right here. So conveniently, I've calculated the mean for you. And so I put in our numbers, and I found that our mean, by taking the average in Excel, was 8.625. So we're going to put in our sample mean for that. And our sample standard deviation is 3.2486. So I'm going to put 3.249, rounding to 3 digits. All right, let's read what the rest of the problem says now. In words, let's state what our random variable x bar represents. And so we're saying, well, does x bar represent the average number of employees that call out for sick for 10 or more days in 1 year? Or the number of sick days taken by an employee in 1 year? or the average number of employees that call out sick, or the average number of sick days an employee takes per year. Well, we're talking about number of sick days, and X bar is an average. So that number that we just saw in our Excel program, that 8.625 does represent the mean of our 8 employees and the mean number of sick days that they take. So let's state the distribution. In this case, we're either going to enter Z or T with a little subscript that represents the degrees of freedom. The degrees of freedom is equal to the sample size minus 1 if we're using a T distribution. And since our sample size is small, we're going to enter in T. And we want to look for symbols right here that we can use. So we're going to use the one right here that says subscript. And in the subscript, that's right here, in the subscript, we're going to enter in our sample size minus 1. So that's 7. There we go. So what is the test statistic? Well, our test statistic is either a Z or a T. Well, we said T above, so it's going to be T. And the T statistic, right, what is the test statistic? What we're looking for is the T value. So I'm going to go to my hypothesis Test-o-matic. My T value is right here, negative 1.197. Negative 1.197. So that's what I'm going to enter in here. It says to 2 decimal places. So that means negative 1.20 when I round up. Negative 1.20. So now we ask, well, what's the p-value? Well, the p-value, remember, is the probability that's associated with our level of confidence right here. And so what we're going to do is the p-level, well, there it is. The Excel program computes this for us. It's based on the T distribution and what the probability is that our population mean falls outside of the outside of the population or the sample confidence level. Right. So what we're going to say right here is that our p-value is 0.27026, but we want 4 decimal places, so 0.2703 is what I'll choose right here. And we're going to ask the question, well, what does that p-value mean for this problem? Well, it says that if, let's see, what does it say? If H0 is false, there's a chance equal to the p-value that the number of sick days is not at least different from 10 as the sample mean is from 10. If H0 is true, then there's a chance that the p-value's average sick days is not at least. If H0 is false, right? Well, what are we testing? Let's go back to our slide, right? Remember, our slides, we're looking for whether or not we're making a type 1 error, right? So we're actually going back and we're looking for a type 1 error. And what is the type 1 error? That's the error of rejecting the null hypothesis when in fact it's true. And so we say that, well, if H0 is true, then there's a chance equal to the p-value that the average number of sick days is at least as different from 10 as the mean of the sample is different from 10. And that's going to be this last one right here. Because when we're looking for a p-value, let me go back to my slide a little bit further on. The p-value of a hypothesis test is the probability of getting a sample data at least as inconsistent with the null hypothesis as the sample data actually obtained. So that's what we just stated. All right, let's sketch a picture. Well, nice thing about my hypothesis Test-o-matic is, hey, look, we've got a sketched picture right here, right? This is our 95% confidence level interval right here that we've just given, and our degrees of freedom is 7. So we're looking for a p-value, and we're saying, well, which picture represents our p-value? Well, it's a two-tailed test. So that means that we're looking for a p-value that is outside of the confidence level. And so we choose this second one right here to represent that, because the shaded area corresponds to that p-value. If our population mean is actually in those shaded areas, then that's our probability of being wrong about that. All right, let's integrate our correct decision to reject or not reject. What's our alpha level? Well, if it's a 95% confidence level, that means our alpha level is 1 minus that, so 0.05. And let's look at our result. If the p-value is less than our alpha, we have enough evidence to reject. Our alpha is 0.5, our p-value is 0.27. Do we have enough evidence to reject that null hypothesis? Well, in this case, the answer is no, we don't. Right? So, we do not reject the null hypothesis. We don't have enough evidence. And the reason is that since the p-value is greater than the alpha value, we don't have enough evidence to reject. And so there's not sufficient evidence to conclude that the average number of sick days used per year is not equal to 10 days. We didn't prove our case. Right? All right, finally, we're going to build our 95% confidence level, or confidence interval. So going back to my hypothesis Test-o-matic, we're saying that, well, our mean was built around our sample mean of 8.625. So we're going to put in our 8.625 as our sample mean. Our 95% confidence level goes from 5.9087, so 5.910 here, and goes up to, oops, wrong thing. There we go. It goes up to 11.341. So 11.341. That's our answer right there. Whew. Okay. I'm going to test this. Hope I didn't miss anything. How'd you do, Professor Peeples? Oh, it logged me off. That's terrible. Okay, well, it's on video, so I'm going to pause my video now.